I'm Art Wiggins again. Yeah, still. And we have a show today that's just going to knock your socks off. It has to do with skidding. And we have an expert on skidding that has joined us. This expert is none other than Jesse Mason.
Howdy,
Hi,
Art.
Jesse. Welcome.
Thank you.
Gee, I can hardly wait because Jesse knows a lot about skidding and skids. Jesse skids through life, one could say, as do we all,
Yeah,
don't we?
sure.
So we're going to talk a lot about skids and see how that all goes. And so let's see, where are we going to start? That's not you, is it?
No, I left mine at home.
Oh, it's me.
Who is it?
I got to take it. I'm sorry.
It's okay.
Iffy? Iffy, are you there? Okay. Iffy, you've never met Jesse, but I'm here doing a show, and I was hoping that Jesse and I could take care of that. Oh, okay. Well, yes, we did talk about dirty molecules in an earlier show, but it was family fare. I mean, it wasn't dirty. It was okay. Oh, there's a problem with it. What was the problem? Oh, it had to do, yeah, okay, I think I still have it. Do you want me to show you again? Iffy has to see this. Iffy is like, he's like my boss, I think. I don't know. Just a minute. See, earlier we had some molecules, molecular models at least, and this one was oil. Remember that one, Iffy, the oil? That's this one. Can you see this one? Whoa. Okay, that's oil. And that's a non-polar molecule. Now we also had molecules of water, and these guys are polar because these polar molecules are ones that have negative ends and positive ends because, see, the oxygen sucks at the electrons more strongly than the hydrogens, and so the electrons spend more time near the chin of this little thing, and the ears tend to be a little positive. So it's positive here, negative there. It's polar. This one is non-polar. They don't work well together. Yes, Iffy, I'm trying to do this. Just hang on. So what happens is this. Soap or detergent molecules will link up with the nonpolar part of the oil, and then they'll link up with the polar parts of the water, and they'll form something called a micelle that chemists love to talk about, I'm sure, and then off they go. So does that do, oh, Iffy. Yeah? Yeah, we had some water. Yeah, it wasn't just the molecule models, it was actually water. You want to see that again? Yeah, we had oil. Oh, we didn't have detergent. Ooh. How did we miss that? Okay, I think I can do it. Yeah, thanks, I'll try. I still have that. You know, I don't throw things away if I hold on to stuff. Hang on. Here's water. Jesse, yeah, I think you've done this demonstration before probably, haven't you?
Perhaps.
Okay. Well, this is the water. Is this the water, Iffy? Okay. Here's oil. This is particularly good oil, olive oil, since I just like vegetable proteins, not animal proteins. So, and here's what we did. We mixed this up together very nicely so that it would work. Ooh, this is a nice color, isn't it? There. Okay, that's good. So, Iffy, that's what you wanted? Iffy, you wanted that? He says I have to shake it up to show that it doesn't mix. Okay. Shake. Isn't that what James Bond says? It's supposed to be shaken, not stirred?
I think so.
Works well for him. Now, see there, all mixed up, right? Well, if you watch it carefully enough, you see that the mixture doesn't last very long because we got the wrong kind of molecules. We have molecules which are non-polar, molecules that are polar, they don't mix well at all. So what you have to have is you have to have detergent. I think that was that your point, Iffy? Thanks. I brought some detergent from home, just in case. So let's see if this detergent will do anything. Now these are molecules that have partially polar ends and some non-polar ends. So put this in there. Ooh, nice color. Makes a color scheme that just won't quit. Iffy, it isn't doing much. Okay, He says, shake it up. Hey. If I don't have this on tight, I'm going to get your bow tie.
Let's not do that.
Oil. I don't want to do that. Okay. If he says, shaken, not stirred. Whoa. Hey, it worked.
It's a good mix.
I'll be darned, it actually did mix. So now what happens? Jason, if that was a beer, you wouldn't drink it, would you? I think it's got too much head on it, doesn't and the color, it's not an IPA. I don't think, no, it's never going to work. But it mixed. You see the difference? Because the molecules that have a polar end and a non-polar end work together in such a way that they then link up to the polar molecules of water, and it all goes together very nicely. Jeez. So, Iffy, he hung up on me. Just when I thought I had him satisfied. Well, I think we ought to get back to what we're trying to do here, because this...
It's probably not the last you'll hear of him.
You know, I really wonder. I wonder where Iffy lives.
Probably in the cloud.
Under the sea?
In the cloud.
In an octopus's garden? On the cloud. Okay, I can understand that. That would make sense. Were we going to do something today?
We were going to talk about skidding.
Skidding. Okay. Oh, right. We're going to skid into something. Let's see. What did we have in the way of skids we were going to show? I think we had some nasty examples of. Oh, get these molecules out of here. Gosh. We had some nasty examples of skidding. Let's see if David has anything that he can show you. There's a skid. Whoa! Guy skidded into a bus. I say guy. I don't know that. There's another one.
It was a cop car he hit.
And sure enough, multiples. Ooh, that's nice.
Dangerous.
So, okay, skidding. Oh, geez, I know about skidding too. You've skidded. I know you have. We're going to show that one. But, you know, I worry about skidding a lot. I live on this nice little side street, and in order to get into my street, I have to turn left from a very busy street. So I'm on this very busy street, and there are cars coming the other way, so I get into the left turn lane, I signal my left turn, but there are people that come up behind me really fast. And I'm looking in the rearview mirror, and I'm thinking, do they see me? Are they texting while driving? Are they not paying attention? Are they distracted drivers? I don't know what they're doing.
There's a good reason not to have your wheel pre-turned in that situation. Because if they do hit you, they'll put you into traffic.
Right into the oncoming lane. So now there's a practical thing for you, and that is, if you're worried about somebody hitting you from behind, sit there with the wheel straight, and you're right, Jesse, I do that. The other thing I do is I'm ready to hit the gas, because if I see somebody come out I think isn't going to make it, I'll hit the gas and go. Maybe he'll skid into me, maybe he won't. I'll turn left at some later point. But we all worry about that stuff because there are an awful lot of auto accidents, as you saw. So, geez, there's a lot of physics here, isn't there? Because we've got collisions. And I think in an earlier program, we dealt with the difference between elastic collisions and inelastic collisions. Elastic collisions were ones where the kinetic energy was conserved, and inelastic collisions were where the bodies stuck together and skidded along like so. And so, you know, there's a group that studies all that stuff. Are those forensics?
Yeah, I'm sure, yes.
So is that why your title, what is your title, Jesse? Let's see that title again. I think I saw a title that said that
Faux
you were
Forensics
a
Physics
faux
Fellow.
Forensics Physics Fellow? Okay, so you know about that stuff.
For today.
That's good. Tomorrow he may know a lot more. I mean, anybody that can wear a tie like that and look that good,
Thanks.
I think he's liable to do almost anything he wants to. My gosh. Jesse did something really neat. Now let's see that video that you shot, Jesse. Let's see, there's a couple different views of it. Here's one. This is you're getting in your car. You're driving your car. We're looking from a policeman's car. Is that the way that works?
That is a policeman's car, yes.
And so what's happening?
I'm backing into place, and then I'm going to floor it.
All right.
And I will be accelerating at the maximum capable acceleration of a Honda Accord.
Until you get to 30 miles an hour, right?
I think that's how fast I was going before I hit the brakes.
Okay.
And the idea was that I was trying to leave a skid mark for forensics to analyze.
Ah, so he's going to make...
So there we go.
Here he goes.
30.
Oh, you see that skidding to a stop?
Yep.
How did you do that?
You can even see the cloud.
Oh, look, this is from the side, I think.
Yeah, maybe this is a side view. I got a couple shots of this. You can see the car changing gears. Slam down the brakes.
There it goes.
Locked up the tires.
Locked up the tires.
Yep.
Now, you can't do that with these ABS systems, can you?
No, but I was driving a manual and it had an emergency brake, so I pulled the emergency brake while simultaneously depressing the
Does the
foot brake.
emergency brake hit all four wheels or only the back?
I think it locks only the back left or the back right. I don't remember.
Oh, really? Oh, that's
So,
why
yeah.
it went off to the side
Yeah,
slightly.
that's why it kind of veered a bit.
Okay.
Yep.
So, well, that makes sense. Now, the policeman, his radar, did we see the radar? Did we see what the radar number was? David, show that again. Because I think there was a radar gun that was on the policeman's dash. Let's see if it shows. Do you see it? Oh, there, see? There, it's telling you how fast you're going. You're going to 22.
It looked like it hit 30.
Hit 30.
Yeah.
It did. Exactly right. So then, here's the interesting part. Jesse knows some physics. And boy, when you know some physics, you can be really dangerous. Jesse's physics enabled him, and he has the calculations right here, enabled him to figure out if he could measure how far the car skidded and what the friction coefficient of the tires on the road were. He could figure out how fast the car was going. Now, how would you find out what the friction coefficient would be? What would that be about?
You have to do that experimentally.
Do you have a gadget?
Yeah, I do. So I have, this is called the spring scale. The spring scale has force units on it. So as you pull this way, it'll tell you what force you're using to pull on this side. And so I was able to measure the force required to move this along at a constant speed, like so. And with that, I can experimentally determine the coefficient of kinetic friction, kinetic because it's moving along the surface between the tire, and I did it on dry concrete, which is what I used when I was skidding.
So really, theoretically, you ought to be having the same tire and the same roadway surface.
Yes.
And that would determine the friction coefficient. Then the other thing you need to know is
How long the skid mark
the
is.
length of skid.
Yep. And so we went out and measured that after the skid, and we were able to perform our calculations to predict how fast the car was going when it entered the skid.
And when you did that, how fast did physics think the car was going?
Physics said the car was going 31.5 miles per hour, which is about 5% off, which is really, really good for an experiment,
Sure.
especially crudely performed.
Well, and especially because you don't know how long ago the policeman's radar had been calibrated, because even that's not 100%, is it?
Yeah, true. Very
So
true.
all those things bear into this. So from physics equations, you can figure out how fast the car was going. Now that could be very important in some legal cases, couldn't it?
I know that for a fact that this is used in forensics when analyzing an accident. I actually got the idea from a student who was a state trooper giving a presentation in my class on how they do it.
Oh, wow.
That was my first brush with this, and I said, this is too cool. I want to bring this into the lab. So I tried to set it up so that students at OCC could go out to the parking lot where this took place, take the measurements, and then get a predicted value for V, the velocity of the car when it entered the skid, and then they could go back and watch the video of the policeman clocking my car.
Wow, that's really interesting. So now, of course, it gets more complicated when we saw some of those crashes before, because it would be not only the one car that would crash, but it might be another car. So you'd have to do a little more physics calculations, measure a little more skids.
Yeah.
I don't know if you've noticed this, but anytime you see an accident on the roadway, often they'll mark off that area where the accident was, and the forensics technicians come in and they make measurements and they do all kinds of stuff. It's the same kind of measurements Jesse was just talking about. It's those measurements that are needed in order to find out what kind of velocities were involved. And if the velocity is greater than the speed limit at that point, uh-oh, ticket time.
You're going to get a ticket, yep.
Yeah, wow. So, and if the cars are turning, then you got to worry about that also.
Yeah, so it turns out that the physics are the same, but the math is a little more complicated when you encounter a curve. And I don't know if you have the clip, but I also did a shot where I was moving the car in a turn, and I was slipping as I was moving. So I was leaving skid marks in kind of a circular fashion. And from those marks, you're able to take a couple measurements. You're able to take an arc length and a chord and what they call a middle ordinate, basically measuring the geometry of that skid mark. But now that it's curved, the math is a little more sophisticated, but at its heart, it's the same physics.
Wow. So the tire manufacturers must love you, because you're skidding and getting all the tread off these tires. You have to buy new tires.
Actually, I waited 2 years to have tires that needed to be replaced before I performed the experiment, because I didn't want to waste new tires on it.
Oh, that was wise.
So when the time was right, at the end of the semester, when students weren't around and the police were able to secure the area from everyone, then we were able to lay the skid marks, and the very next day I went out and bought new tires.
Well, that's very good. That's conservation of resources at its best, I swear. That works out very well. So then besides this, I happen to know that Jesse does a number of other things. Jesse spends a lot of time at OCC in the physics lab, but he does some other things as well. And wanted to talk to you about the other things that you do. I think we have a graphic. I found this on the internet. Maybe put that graphic in. Now that's you. Is that the same bow tie?
That's the exact same bow tie.
Oh, wow. That he's wearing
I told you
today?
it was my favorite bow tie.
Ah. Now, you're wearing glasses that look like...
I'm wearing protective goggles. That day in lab, I had somebody take that shot because I thought it was a neat moment in lab. It was when I was repairing a laser with a hockey puck.
Ooh.
I was recollimating a laser that had been dropped by a clumsy lab tech. And so I was recollimating it, and I had it on my workbench, and I thought, this is a neat picture. I should take a picture of this. So I think that's my YouTube avatar.
I think it is.
For my YouTube channel, yeah.
Wow. Now, do you have a name for that avatar that on YouTube?
The name of the channel?
Yeah.
The name of the channel is, I think it's just Jesse Lee Mason, maybe, or Moosey the Juiceman. Whatever it is, it's poorly chosen. When I went to rename the channel, I didn't read the fine print, which is whatever you name it here, it's going to be forever.
Forever.
And so when my YouTube aspirations started taking form, I had already selected a name, and it should be Teach Me, which is what I collectively call my physics videos, but it may be called something else.
So that's the other thing. You could watch on YouTube Jesse's physics videos, and it would be under the name Teach Me. Would that be?
The
easiest that way?
I think the easiest way to find it. I tell people, don't look up my name, don't look up Teach Me. Just look up how to solve any physics problem.
Ooh.
That is my video.
Wow, what a great way to go! Now I think we have another graphic of Jesse that I think I found. I'm not sure I found this one. I think this is you drinking coffee, isn't it?
This is when I discovered butter coffee.
Butter coffee.
Yeah, this is I think the second or third time I had butter coffee, and I was.
You were liking it.
I'm an avid fan now. Yes, yes. I put butter in my coffee in the morning.
Wow. Now, do you then not put it on your toast?
I don't have toast yet.
Well, now see, he's combined two activities. That's another conservation principle involved here. He has his butter with his coffee. Doesn't need any toast.
Yep.
That makes life easier. You must have a lot of duties in the morning to keep you busy.
At school, yes.
Well, I was thinking at home too, maybe.
Yeah. Oh well, I have 4 children, so I need every calorie I can get.
Wow. Jesse has some other talents besides these. Some of these have to do with playing a guitar in a group, and I think we have a group picture too to show you. This is the group Millish.
That's from back in the day. Yes, that's probably a 12-year-old picture, 14 years.
You don't look any different, Jesse.
Thanks.
Maybe a little more
gray,
a little more white in the beard, but it'll take you a while to get to my level, I think. But
yeah, still very good friends with these guys. We don't play as often as we used to, but
Really? Now, what kind of music do you play, and where do you play?
So this was an Irish band. The redhead gentleman I met in a pub at a jam session, and he was looking for guitars for his band, and I joined. And shortly after, the fiddler came along, and then the percussionist, and we started touring together, and we spent the better part of a decade together, as close as brothers, making music.
Wow, that's cool.
It was very cool.
I bet you had a lot of fun.
We did, and we saw a lot of interesting places. We got to tour Germany and Scotland and Ireland and much of the Midwest.
Oh, wow.
Yeah, we had a lot of fun.
What a combination.
Yep.
Wow. So Jesse's been around the world, and yet he still does physics and enjoys physics.
I do.
And
in fact, when I was in Germany, I remember we were touring a different place every night, and I was still in grad school. And I remember backstage after sound check, waiting for our band to go on. I remember studying quantum physics, thinking, I'm studying quantum physics in Germany. This is so cool.
Waiting for a band
where it was
to go
born. Yeah, waiting for our slot to come up.
Wow. I love the quote that says, if you think you understand quantum physics, it means you probably don't.
Very true. Very true.
So a lot to be said for that. Jesse's working at quantum physics, and I would recommend watching what Jesse's liable to do, because he has an internet presence that will help you to understand physics at a much more detailed level than this program ever tries to do. And Jesse's not done. He's not done by a long shot. He has a long ways to go in physics, in music, in family, you name it. Any long-term goals that you want to share with us?
I'm currently working at OCC and teaching at Eastern part-time. I'm building my resume to hopefully teach full-time at some point. That said, the more I do physics videos on YouTube, the more physics videos I want to do on YouTube. So,
so you and video get along pretty well, don't you?
I probably won't stop making physics videos ever.
Yeah, right.
I'll stop ticking before the videos do.
Well, so then, does this qualify as a physics video? Maybe it's not.
Why not?
Sounds good to me.
Close enough.
All right. Hey, thanks an awful lot, Jesse. Sure appreciate it
My
having
pleasure.
you come by. My golly. So now we know about Skidz, and we took care of Iffy for the moment. I'm not sure that we've totally taken care of Iffy. You never know about him. You can call it any time. So until next time, I'm Art Wiggins.